going to introduce what we're going to be doing in computer revision. It's just 1:05 now, so we started a little bit later than normal. If you are joining us, then what I'm going to do is just to explain the agenda. Okay, so what you'll see here is essentially a section of selection of Section A questions to start off with. And Section A questions could be basically anything from the theory. What I do have is our chat window open, so if you do have any questions, please go to your Q&A, which is at the top right hand of the screen if you're watching us live, and just add a new question. You may well be able to see the answer questions, but I will try and do that in the video as well. So our agenda should be Section A, which should be your theory. Theory covers a range of different topics, and there'll also be Section D. I'm actually going to ignore Section B for now because that's going to be programming directly from an algorithm. That should be something you need to be doing as a practice. Make sure, please, that you've downloaded all of the past papers. There are some really good Section Bs in there. Your alternative is to go to somewhere like Project Euler and try some of their easier questions on there. There are some particularly difficult ones, but do try and have a go at them. The better that you are at reading an algorithm, the easier it is that you're going to be able to do in programming. During this particular presentation, what I'm going to try and do is to have Section D questions specifically to Pascal and Python 3. Now, I will give a little bit of a disclaimer in here. I teach Python, but to GCSE level. I have looked at the pre-release in Python, and I will do my absolute best, but I have been teaching it in Pascal. Okay. So what I'm going to do very quickly is to move on and look through some of our Section A questions. Now, again, I'm just going to recap on that one. So Section A is all of your theory. So this should be approximately 30 minutes worth. And I can't guarantee what's going to be in there. Nobody knows until the day. But here what you've got, this is from the CAS website, so I've cut and pasted this from our Excel. And on here, this is basically like a checklist of everything that you need to have covered. So you should have been looking at your stages of problem solving, making sure that you understand finite state machines. Finite state machines, looking at not just what they do, but also your finite state diagrams, so that you can actually draw those diagrams or fill in the blanks, which is more likely. You've also got algorithm design. That one is really important. If you look down here, you've actually got where they've come in the recent questions. You can see in 2014, we had pretty good selection of pretty much everything on there. We had stages of problem solving, which hasn't come up an awful lot, but may well continue to do so. Finite state machines haven't come up for a couple of years, sorry, for a year, but quite likely to do so again. It is a major topic in the actual program. Algorithms would be in absolutely everything. You need to be able to read an algorithm. You need to be able to read that not just in pseudocode, but also in flowchart formula, and make sure that you can go through those. Make sure you've gone through these past paper questions. Pseudocode flowcharts, there you go, you can see every year. It's going to be there. You need to be able to do your trace tables. And there you go, there's trace tables again. So let's look at a couple of questions that my students are giving me up front. There are a couple of questions that you guys left me already. So here you've got a past paper question. We've gone in there, we've tried to get somebody to redo this for us. Apologies, it's not massively in line there, but this is one from last year. So what they did is they gave you a one-dimensional array, gave you some pseudocode, and then expected you to be able to follow that pseudocode in order to pass this data into this one here. And what it's asking you to do is one pass is made through the outer loop of an algorithm, complete table 2. So table 2 is the important bit, it's this bit here, to show what would happen if just a single pass had been done. So all of you that managed to put this into completely sorted order didn't actually get it correct. What they're asking for there is how many, where would this go if we just do a single pass? So remember what we're looking for here. You've got a for loop within a for loop, so you've got nested statements, and actually what they're looking at here is bubble sort. Now, bubble sort, again, it's the only sorting algorithm that you need to know for COMP1. It's worth knowing some of the others, but the actual algorithm itself for bubble sort is the one that they expect you to know for COMP1. If you're looking for searching, you need to understand linear search, which is to go through this array here and go one by one by one, searching for the piece of data that you want. Okay, so bubble sorting was one that we needed to know. They expected you to go through this pseudocode using this bit here, basically just as a table to work it out in your head. The bit that you needed to put into your electronic answer document was this table 2. And then finally, for just that final 1 mark, you needed to identify that it was bubble sort. Okay, so looking at trace tables. Trace tables, they may well give you a table to fill in. You can see here, they've given a table 1, the thing that you had to have, that's 6 whole marks just for 1 table. So if you can't do trace tables, it's really important to give that another go. Sorry, I'm stumbling here because my internet's gone a bit squiffy. Okay, right, so let's move on. On this one here, they ask you to dry run an algorithm. That basically means to run through, do a finger trace with it and write it out into your table here. So dry running is basically filling in your trace table. And again, for that final mark at the end, they wanted to know what it is that this entire algorithm is trying to do. Ultimately, that 1 mark is droppable if you can get all 6 marks on your trace table. It's far better to get all 7. The more marks you get at this early stage, absolutely better. Okay, so let's move on to the next section. Now, the next section is programming. This is going to be the really heavy one because, of course, for COMP1, it is an awful lot to do with programming. You need to understand the input, the output, data types, constants, all of those variable types. But you also need to understand here things like your selective statements. So your most basic one obviously being an if statement, but you need to understand else if, or in the case of Python, elif. What happens if you nest an if statement? What happens if you are going to use a case statement? Now, this could be particularly difficult for you guys who are using Python. For you people who we're teaching Pascal to, brilliant, we've got loads of case statements and we've been using those quite regularly. But for Python, they don't actually have a case statement. So you are having to use this long else if statement, whereas a case statement will pop in, it will run the single line of code where the statement is correct, so where it's found that Boolean statement to be true, and then it breaks out of the if statement. Iteration, I can just see that that is actually spelt wrong there, but iteration, iter in Latin being to repeat something, so you need to understand for loops and while loops. It's also very important for you when you're looking at your while loops to understand also that we have a do while loop. Now, if I just very, very quickly, and I know I'm probably teaching you to suck eggs at this point, tell you that a for loop runs this for a set number of iterations. A while loop will continue to repeat until you have got a condition which has no longer been met. So it will just continue repeating until that condition is no longer met. Now, a do while loop, or a do until loop if you're in Pascal, will do something slightly different. It will go through, it will run it at least once, and then it will repeat until that condition is no longer met, which is slightly different. Okay, so arrays, you need to understand one-dimensional arrays. You certainly will be able to understand two-dimensional arrays because it's the entire essentially the entirety of your pre-release. Everything about Capture the Sarum is working on two-dimensional arrays. One thing you probably want to be aware of in terms of arrays is that an array can hold a single data type, whereas if we need to hold more than one data type, we're going to have to use a record, and a record will hold different data types. If you do an array of records, it gives you that two-dimensional array, but actually in different data types. Whereas if you have an array of something, it is just a single data type. Okay, so you need to understand reading to files, writing to files, and I'm going to go through that one in a little bit more detail. One of the main reasons is that some of our ideas on where this great big 18 marker comes up at the end, something possibly to do with the which, could be writing to files. We're not entirely sure. They haven't given you any files to read, so it could well be a section C question. Okay, we also need to know error checking. I'm not going to run through that one in particularly much detail today, but I will give you a link of some other videos that we've done on Hamming code, on grey code. Make sure that you've practiced that by hand. Right, moving on. I don't want to spend too much time on this one, but reading from a file. Okay, so I've got some information on here on a couple of very, very quick things that I've produced for you. To read stuff from files, so to read from files, we're going to look at Pascal and we're going to look at Python. Now, you guys who are doing Python, you get to gloat at this point, because actually to write and read from a file in Python is an awful lot quicker than it is in Pascal. Pascal's a slightly older language. Okay, so here you need to set up your variables. We've got the file, which is essentially the text from the file. We have a file name, and for our Pascal one, we've also got a T file, which is a string as well. Now, the first thing we're going to do is we're going to ask which file we're going to read, because we want to give them the file number, file name. We're going to read that line in, or we are going to input that line into our variable. We then have to work out which file we're going to open. Now, you can see down here we're assigning. So especially if you're using Pascal, you need to know that what we're using is assign and reset. Those are your key terms there. You need to assign. You're assigning the file, which is a piece of text, which is different to a string. And we are assigning all of the text within filename.txt. So we're only asking them to write in the file name, not the .txt at the end. We then reset it. Now, resetting is to open the file in read mode. Now, if we go over to Python, what we're doing is we're taking that file name, we're putting its .txt, we do the file equals open, and we open it using an R for read. Again, it's an awful lot easier than to reset it, but R for read, if you can remember in Python. And then to read out, we used a repeat until over in Pascal. So we repeat read line rather than write line, the file of T file. So what we do is read this into T file, which is a string, so each line, and then we write the line out until end of file, EOF, end of file. Now this one, for line in the file, print line, and then end. That's so much easier. Now, the one thing that I have done for this one, which I really ought to have done for Python, is that I've used close. Close the file. If you don't close your file, it's not going to work. Ultimately, if you don't close your file, it may well cause a massive error, and you need to make sure that you are being very, very strict about making sure that you open your files, you close your files, because if you then try and use that file again later, especially if you want to write to it, it's not going to work. Okay, so what I'm going to do, I'm actually going to run these files. Now, that one is my append one, so I'm going to just open this one here. So if I want to read something, what I can do, let's just close that, there we go. If I want to read my file, you can see that is exactly the same one there, and let's just run that. Now, I will just prove to you that it works, because there you go, a file is my file there. That's what it should look like. So I should see line 1, this is line 2, keep reading, and then it's not actually that interesting, is it? So let's run this one. And again, you're going to see something very, very different in terms of Python and Pascal. So this is what you should see if you're running in Python. Now, just be aware that I'm running Python 3.3, not the 3.4 that you have been given all of your coding. It does actually work in 3.3. There may well be bugs that I haven't found, though, so don't quote me. Okay, so let's have a look. Let's read a file, because that's what we call it. We don't need the .txt because we're adding that into our file programmatically. So there you go, it's gone in, read the file line by line, and then popped it onto the screen. Okay, I'm just going to close my shell for now. Now, if you wanted to do that over here in Lazarus, now I'm using Lazarus for Pascal. Some of you might be using something else, but this is our free editor. And you can see there the code's slightly longer. I need to use assign to start off with, then reset, and then I'm using my repeat until. So remember, repeat until always does it at least once. So it will repeat all of this until end of file. So the condition is tested at the end. And that's also known as a post test. Okay, so F9 to do this one, not F5 anymore. So which file should we read? Same thing. The file, I've put exactly the same file in this folder. So again, there you go, and you'll see that this one will run this as an executable rather than in the shell. Okay, so let's move on just a little bit more. Our next one here is, so we can read from a file. It's quite useful to be able to write to a file, but we're going to start off by just writing a new file. Here you've got exactly the same thing. So if you can write something which reads from a file, you can always take that code and you can adjust it so that it does something else. So here I've kept my variables the same, except I've added an extra one called entry. And again, if you look at the Python one, you don't actually have to declare any of your variables, you just use them. So the first time you make an assignment statement, it creates that variable, whereas in Pascal, you actually have to physically create each one of your variables. So here, let's have a look. So which file should we overwrite? So we changed our initial message. We read line, well, you're inputting and then into file name, so same sort of thing. Again, in Pascal, you're using assign, but rather than assign, and if you look there, reset, assign and rewrite. Rewrite essentially opens the file in write mode. We're writing over the top, we're taking everything and we are getting rid of it and putting something new in there. And the same over here, if you look at open file name. Now, I've done something slightly different in Python, and this is because I've used slightly better coding standards. I've used a W to write, but when you're writing to a file, to make sure that the file is closed properly, I've put with open file name as the file. So I'm creating the file being the file that's open, but I have opened it with a specific name. And then what I can then do at the end is I can just put the file.closed, and that makes sure that my file is closed properly, and then I can overwrite it. Okay, so let's have a look. So entry equals input what do you want to save, and then we write that one line. So here, what do you want to save? Read line into entry, entry being our string variable, and then we write line. Now this is the bit in Pascal that you need to be aware of. The write line, if you want to write to a file, you have to write line, the file name, and then what you want to write to the file. So let's go and have a look at that again in practice. Here's my Python files here, and we want to write file. Now we're going to write, let's have a look here. So we've got hello world already in write file. We're going to run this. I have to run this properly, aren't I? Let's have a quick look. Let's make sure I have this open. Otherwise, it's going to open this in command line and it's not going to work. Okay, so I apologise, I will keep this open next time. There we go, 2015 Python. Okay, so we want to write our file. There it is. Okay, so here we are doing exactly, you can see this is exactly the same as this over here in the presentation. Now I'm going to write to that folder, so we want it to go to write file. Let's have a quick look. Okay, so it's saying to us what file should we overwrite. Well, let's overwrite the write file because that's what we then we said hello world, so we want to overwrite it with something that's already been done. So let's have a quick look. So what do you want to save? I want to save Paul. Okay, now that appears to have done nothing. So let's close that down and open up our write file again. That's overwritten what was there and now written hello people. Okay, so I'm going to do the same with our Lazarus. Let's just open this. Now you can see the difference here with my Python files. I can put them all into one folder. If I'm in Pascal, if I want to create different files, I need to put them into different folders. Otherwise, they will start overwriting each other. When you're doing this in the exam, please do make sure that you create different folders for all of the different tasks. It is a really good practice for you, unless you're doing a task which requires you to have done something already, to take a clean copy of that pre-release, put it into a new file, and give it a question number. Okay, so let's write some stuff to the files. Here we go. So write stuff to files. Remember, we've got these things here. We've got a new variable called entry. That's of type string. And again, here we've got this assign, and rather than the one that we had before, we're now using rewrite. So we're writing the file. Okay. So it's the same file name, hopefully. Write file. What do you want to save? We've got hello world in there at the moment, so I don't know. Let's put in we are on Google Hangouts. Okay. Now, the one thing with Pascal is that you put this read line at the end just to keep command line open. Otherwise, it's going to just close everything in the program and you won't see anything. Okay, so let's go and see if that's actually written to my file. There we go. Right, it was write file. There you go, we're on Google Hangouts. So that's all very well. If they ask you to write something and just save things, or you need to save a small piece of data and it never needs to be used again, so it might be saving your progress. That's one thing that might come up in the exam, maybe. Alternatively, what happens if you need to change it to append to a file? Now, I'm not going to run this one because we need to move on. But to actually append something, you only need to change a very, very small amount of code. So if you write to a file using Pascal, the only thing that you need to change in that entire program is this bit here, which is rather than rewrite, it's append. A simple change will then stick that at the end. And for Python, it's slightly different. Rather than having your W for writing, it's A+, which is to append plus. It means to write it and then add something on the end. But the other thing that you need to do is when you write something, you're going to need to put a \n in there to put a new line. Otherwise, it's just going to write it a long line. Okay, very quickly, let's move on. Data representation. This is where everybody gets a little bit confused. Make sure, please, that you have gone through and you are looking at all of the representing numbers, looking at two's complement, making sure that you've done all of your practice on binary. Error checking could be quite a big one, and there's always going to be at least images or sound, possibly both. Now, there are lots and lots of things that we've already done. You can have a look on our YouTube channel already to see what we've already done. On here, so that is how you find things like how hexadecimal. There was an interesting question on there on how do you hexadecimal. I will give you a link to the YouTube channel at the end, but we've done quite a few videos on various bits of binary hexadecimal images as well. I will very quickly run through some of the questions that I've been asked on sound. Now on sound, we've got everything which essentially they're going to relate to Nyquist's theorem. A lot of the questions that were asked, I'm just going to move that over a little bit, we look at the mark scheme and actually you get given a mark for using the term Nyquist's theorem. So try and get that one into your flashcards, make sure that you understand what it is. So the first thing we need to be aware of is what is Nyquist's theorem, and that states the minimum sampling rate should be twice the highest frequency. Now remember that your frequency is this thing here, it's the number of waves. I know for some of you that don't do physics, this looks really scary. Actually, it's really not. And your amplitude is the height of the waves. So the highest frequency is the number of waves in a second. Be very, very careful that you are looking at the number that they've given you down here, because when they say time in seconds, a lot of people saw that and went, oh, that's 1 second. I know exactly how to do that. Actually, it wasn't. It was 0.01 second. So in order for us to get the waves per second, we had to do some calculations. Here we worked out actually there are 300 waves per second, and because of Nyquist's theorem, what we've got is if there are 300 waves per second, our sampling rate has to be twice the highest frequency, so therefore it's 300 times 2, ended up being 600 hertz. So make sure that you include all of your working. It's worth showing in here that you've gone through this process, especially when you're talking about calculations, because if they can see that you're going through a process, you may well be given marks for some of your workings, even if finally, because you didn't have a calculator in your hand, it wasn't perfect. But definitely if you see this sort of thing, trying to work out what it is, the minimum sampling rate, always refer to Nyquist's theorem. Okay, this one here described clearly the steps. Well, your analog to digital converter, what it's doing is it's taking this green wave here. Now this green wave is your sound wave. That is your analog sound wave, which works out sound in continuous steps. It's continually changing. However, we can't have continuous changing in a digital wave, so it has to take discrete samples, and they have to be done at regular intervals. This is where Nyquist's theorem came in. We have to take them at twice the frequency. So each one of these little arrows is a measurement. That's when a sample is taken, and a sample measures the height of the wave, and it converts that into an integer. That integer is then converted into binary, and you can see those binary numbers down here. That's then saved as a bit pattern. So our bit pattern can then be transferred back into these measurements on a wave, and then converted back out into this almost smooth analog wave. Okay, let's keep going. Be aware that you can do various different things. You need to be aware of some things like MIDI and WAV files. Just be aware what they do. You need to know why we sample. We need to understand what synthesizing music is, and I generally try and get something which is a synthesized sound. If you think back to the sort of the 80s and the 70s, a synthesizer was something which was used to create the sound of real instruments. It was a cheaper alternative. Doesn't always sound brilliant though. Okay, so other data other than the note itself, we could be looking at something which has amplitude. It could be the volume of that particular sound. It could be an effect, so pitch bending. Could it be that we're going to put like a pedal effect because we're using a guitar? Very much dependent, but we need to know the length specifically or duration of the note when it starts. But if you just put in there the note, the key, the pitch, or the frequency, that is not enough. So we're looking specifically at effects. Okay, we're nearly there. You can see there, again, they gave the bit pattern. What sampling resolution has been used? Well, we need to know what resolution is. Again, it's asking you to refer to Nyquist's theorem. We're going back to Nyquist's theorem here. And it tells you here that sampling rate is 44,000 hertz. Okay, you can just give the formula. Now, 1 hertz is 1 sample per second. So each nibble is representing 1 sample. So this is just 1 sample here. Because we've got 4 nibbles per row, this is suggesting here that you've got 16 bits per row. So 2 bytes, 16 bits, you've got 16-bit resolution. Okay, and again, they asked the next question, which was the original signal lasts 100 seconds, how many bytes of storage? Well, here you'd be awarded for 100, so we've got 100 seconds times 2, because Nyquist's theorem, times 44,000, that would be your mark. But if you actually worked it out to 88, then that would be okay. So if the average human can hear in frequencies of 20,000, explain my sampling rate. Again, we can use that Nyquist theorem banner, because if I can hear Hertz 20,000, what I can do is I need to take samples at 40,000, because then I can pick up all the peaks and the troughs. Because if I did it at 20,000, I'd only collect the middle. So you can see here, the frequency does this, but this is my 0, so it needs to go peaks and troughs, peaks and troughs. Obviously, no real wave actually looks like this. Okay, very, very quickly through the system life cycle. Let's go through this at a rate of knots. You need to know the stages of the system's development life cycle. You need to know that there's analysis, design, implementation, testing, and evaluation. Now, anybody that has created code all the way through this year has already run through that. You may well have not realized that you were running through it, but you have. Certainly when you do your project, you will know this cycle very, very well. In terms of testing, you need to understand what a dry run test is. So can I take my algorithm and can I dry run it? You've already done that. We've already explained that before. Black box testing is to test without seeing the code. So imagine a black box in an aeroplane. I can't see what's going on inside it. I only need to know that it works. White box testing, I can see the code. So I'm testing my code to make sure that it does what I think it does. And test data, to be able to give somebody the data so that they can replicate that test. So if I get some horrible error, I can take that same data and I can replicate that horrible error again. Okay, very quickly, let's have a look. This is your system development life cycle in an actual cycle. This is what you'll probably be most used to seeing it. However, you need to know the different methods of development using this system life cycle. The first being the waterfall method, which is something which is used most often in academics. So we start off with our analysis, we go all the way down the waterfall, and we can go back up, but then we have to then follow all of those different stages again. So imagine that it's a waterfall because we're falling. You have to complete this stage before this stage, complete this stage before this stage, or I could be like a salmon and I could go all the way back up my waterfall to analysis, but then I have to go back to design and then implementation. So I have to keep going down my waterfall. And in order for us to do an iterative model, we have to go all the way through it and back up to the beginning again. So this one here is a spiral. We do a smaller version of our project and we go all the way through the life cycle. We do another version of our project, but it contains more modules and it contains greater functionality, and we continue to spiral this and we continue to do larger and larger spirals of the system development life cycle until we have what's known as an onion system, which means that you are now developing for something which is absolutely massive. Okay, some of you may well have come across Agile. It's known in the syllabus as RAD. RAD is actually a prior development of the Agile model, but Agile is essentially what is used out in industry now. It's the industry standard. We would go through something which constantly has visibility for the clients. Our user is involved at every single stage, and rather than doing a large project and then producing something at the very end, what you do is you do small life cycles to add functionality. So you create a module and then you present it live, and then you work out what it is that they want you to do next, and you go away and you do another iteration. These are known as sprints, these small development life cycles, and what they do is you will go away for somewhere between 7 to 14 days, create something, then go and show it live, go away again, create something even better, and come back. So they can really see that you are actually creating something, and it just brings your clients in there. But if you're looking at developments, it's quite likely you'll be asked about the waterfall or the spiral method. Okay, we're going to move on to section D and have a look at some possible solutions to that pre-release. Again, I have to put that disclaimer in there. I have absolutely no idea what's coming up in the exam, but we are doing our best to gauge possibly what might happen. Okay, so we started off with somebody asking, what is a SARM? Well, that one really is in your pre-release material, and I highly suggest that you read all the way through that and make sure that you're very, very familiar with it before you walk into the exam. SARM is a king. Some of you may well have already come across these little things that we created so that we could actually physically play the game. Do try and physically play the game so that you know how it works. It's not that dissimilar to chess. Our SARM, that's our king, one square in any direction, exactly the same as a king in chess. Our Mars Panai, our royal attendant, seems a bit rubbish, actually, from the way that we've been playing with it. It can only move one square at a time, either vertically or horizontally. We came up with an idea, perhaps, that maybe the Mars Panai could be asked to change the way it works and actually change it into something more akin to a knight in chess. And there is a way of doing that quite easily using the absolute function, which they've already given you. The Naboo, the seer, can move one square at a time along a diagonal. It can't make horizontal and vertical moves, so they've already shown you. This is quite interesting. One that can move vertically, horizontally. One that can move diagonally, but not vertically and horizontally. So they've almost given you all the possible moves there. Etlu, who's your warrior, 2 squares. But it must move exactly 2 squares and it cannot make diagonal moves. And Etlu could also perhaps be turned into a knight if you go exactly 2 squares forward and exactly 1 square left or right. Now Giskazir, which is taking, I think, about 3 months to work out how to pronounce it, can move any number of squares at a time, vertical or horizontal. Can't make diagonal moves and it can't jump. So they've already given you code there to stop it from moving past other players. Our Redens, which are our pawns, I think. A Redden can move forward 1 square at a time. It can't take diagonally. It can take diagonally. It can't move diagonally unless it's taking another player. And from what we could gather, you can't take moving forward, so you have to take diagonally. It's definitely worth going through all of those check move is legal functions just to make sure you really understand how those bits of code work. Okay, and next question, Cameron. You asked me, how is the witch programmed into the code? So all your solutions at the moment resulting in moving anywhere. And you're using Python 3. I'm going to try and show you in both languages so that you can see what's gone on. Okay, so some of the things that we tried to come up with, our Kachepsu, so our witch, we thought that perhaps it's not in play until a Redden is promoted. So maybe a little bit like, instead of the Mars Panai arriving in the other end, the Redden could be promoted to a witch. Let's have a quick look at how this works. So this one was solved by one of our students. Thank you, Lewis. And yes, I am using your code. You can see here the check move is legal. We've got a check this one, the check the witch move is legal. The first thing you need to do when you're doing something like this is to find a similar function, and it allows you to set up that function. So if you look, if I just move this to the side, if you see here, Lewis has used this one here, has pasted it here and changed what he needs to. So you can see that Etlu has become the Kashaptu. But all of excuse me, sorry. All of our code is essentially the same. So we still have our local variables. We're passing in parameters. So you can see up here, we're being passed in board, we're being passed in start rank and start file. So the way that it's been set up is absolutely the same, and you've got your beginning and your end, so you don't have to worry about making sure that your scope is set up. Here, it's just changed a few little bits here. So the if statements have been changed so that they can move in any direction, but also that it stays on the board. So you've got here finish rank is less than 9. Now, less than 9 could technically use one of our global variables. It's not actually a variable, it's a constant. Technically, if the finish rank is less than the board dimension, you would then be able to change this through the code. Whereas if I change board dimension at this point, it may well then break the code. this one here with the rank difference and the file difference is just making sure that it's the same, to make sure that they're just moving in one particular direction. So you couldn't move 1 to the left and 4 forward. It has to either be horizontal or either be vertical. Okay, so the other thing that you need to do is, if you create any extra pieces, is you need to make sure that this case statement is updated. Now in Python it's slightly different, and I'm going to show you what that looks like in your Python code in just a second. So you need to make sure your K move is legal, and then check Kashaptu is legal. Finally, what they had to do is to put an if statement in there, to ensure that only one which can be initialized on each team. So if whose turn is B, our black Kashaptu could only be used if there wasn't already a black Kashaptu on the board. And there's a Boolean, nice simple Boolean global variable used for that one. So if you are using Python, this is what your case statement looks like. You've got if move is legal equals true, if piece type equals R, E, you'll then have to put a K with another elif underneath there. So just be aware up here, I'm just saying, be very, very aware that the case statement is not using Python. So if they do ask you in the exam about case statements, just check that you have created something in a different language. You can use case statements and all sorts of things. If you want a nice easy one, have a look at JavaScript. You can use case statements there. Okay, so, and again, you're going to need this one. And between Pascal and Python, it's reasonably easy to change these over. Okay, well, that wasn't the only thing that we came up with, which might possibly do. I think we ended up with about 8 of them. There's loads of stuff if you look on the wiki book, which some teachers have created for this one, and we've added some of our own on there. Okay, perhaps the Kashaptu is a witch who could move any number of squares in any diagonal direction, but we couldn't maybe allow them to jump players. So what we're looking at here is we're looking at a sort of Giskazir who can jump. So if we were to move on here, what Ben did was he used a little bit of stepwise refinement to work out what it is that he needed to do. And this is a really good way of doing this in the exam. So just try and create for yourself a couple of notes, even if you have to just scribble them on a piece of paper. What is it that I actually need to do for this question? Well, here he's written it down. He needed to make the board 9 by 9 because I asked them to have an extra piece on the board. Make the Kashaptu move in a diagonal direction, and also make it jump players. So first thing to do, make it 9 by 9. You can see there, rather than putting 9 by 9 when he set up the board using initialized board, he just changed the constant board dimension. This is exactly the same in Python. Just change board dimension to whatever they've asked you to do. Okay, and you can see there, because you've got T-board is 1 to board dimension, it'll go up to 9. You can see that's worked there. Okay, well, what was the next thing that he did? Let's have a look. So he said, make Kashaptu move in a diagonal direction. Well, he needed to place that Kashaptu on the board, and also added that to the case statement, or the elif statement if you are working in Python. So making sure that he's added those particular pieces in there. So that's that case file number there. That is the initialized board, and that's initialized board as well there. And then using check Nabu move is legal because that was the one that allowed you to move in a diagonal direction. And what he's done is he's then created check Kashaptu move is legal. So it's taking a similar move and allowing them to do the same sort of thing. So here, if your absolute finish file minus start file equals absolute finish rank minus start rank, it means that you've moved in a diagonal direction, which means that your move is legal. What he's done here is to show what he's actually created in his code. He's used the snipping tool, and inside your snipping tool, and I will show you here, if I was to go and grab something like this, I could use my snipping tool up here. I've got like a highlighter, and I could say maybe that is the bit that I'm changing. It's quite useful, and then what you can do is you can copy and you can paste that directly into your electronic answer document. It means if you're using the snipping tool, you don't have to worry about cropping your images, and it makes it a little bit quicker in the exam itself. Okay, I'm going to go through a couple more very, very quickly, just to give you an idea of the kind of things that we have been looking at. Our Kashaptu here, we thought perhaps a Kashaptu may be a witch that maybe respawned into a random square, so where there is no other piece. So you would need to go back here, and rather than creating a check move is legal, actually have a different function which respawns. So you take in a start rank, but you don't have a finish rank and file. What you have is you create that using a different function, or in fact a procedure would work. So that would need to be something within make move that you would change that to say that if your first thing that you selected was actually the Kashaptu, then you don't ask them for the finish and finish rank and file. You generate that. What else did we think? We thought perhaps a Kashaptu is a witch who could move in any direction, but maybe they can't be invoked until the player has made at least 7 moves. So you're going to need to have maybe some global variables there which would count the number of moves that each player has made, and then you can start moving your witch around. Or maybe she could appear somewhere on the screen at random after 7 moves. So like your extra piece appears. We don't know what the witch is for. We don't know even if they're going to use a witch in the actual thing. They have hinted, but that doesn't mean to say that it's going to be in there. Your guess is essentially as good as mine at the moment. So what I'm going to suggest that you do is to make use of some of these links. Other things that you can do, obviously there's plenty of help out there. There's lots of YouTube videos at the moment. This particular one, our YouTube channel is there, so if you want to go and subscribe to that, there are other videos on there to help. We also post help on Twitter, and there's also the wiki book. That's absolutely nothing to do with us whatsoever, but it's incredibly useful for the A-level. It will continue to be useful next year as well, whilst you start your projects. Okay, I'm going to just open up Hangouts again and put it out there for you and say, how can I help? Ask your questions now. Okay. So we're going to have a quick look into chat. Other things that you could do, you could, let's have a look. You could look at maybe looking at some of your section B questions. There are some section C questions which are quite interesting. Certainly going through the different types of variable. Different types of variable being your stepper variables, making sure that you understand those. You could look at your different styles of variables, go through your pre-release, making sure that your pre-release is identifying certain types of variables. So try and look into try and look into areas where you might identify a stepper variable. Where can you identify a constant? Can you explain how an array works specifically within that that particular pre-release? Okay, I will of course leave this online, so if you have any more questions, please do pop those on there, and I will try and answer them in text. But thank you very much for watching, and really good luck with your exam.